Welcome to the third lectures of fax devices. Today we will discuss the switch realization, that is most important to realize the fax. Now we shall start with our simple concept of single pole single throw switch. So where current, where it can block voltage and current by in bidirectional, and it can flow the current also bidirectional. So we require to actually realize this mechanical switch by the semiconductor switch. So we shall see in consecutive slides how it is possible. Let us take a simple DC to DC converter. This figure 2.1 is a buck converter. Here this has been realized by single pole double throw switch. So this switch can be positioned 1 or 2 depending on the requirement. One power flow goes to the point, let us say point A to point B, then switch is connected in the position 1, and when we require to actually connect to the position 2 for freewheeling time, so then it will be in a position 2. Same thing, it can be realized by these two switches of SPST. So it is the VA and it will block the voltage VA and current will pass through it, and it will this switch will block, the lower switch will block the voltage VB and current will be passing through it. But generally what happen, most of the semiconductor switch, you will see that current will allow to flow this direction, not in this direction, and similarly current will be allowed to flow in this direction and this not this direction. So based on the quadrant of operation, we can put different kind of switch. Simple single pole single throw switch, actually it has an on state and off state, it has been shown here. So this is its blocking potential. This axis stands for the V and this axis stands for I. So we will have actually it can block this much of potential and it can block this much of actually on state current can flow in this direction. So in this zone it can conduct and this zone it can block. So this is called a single quadrant operation of the switches. We shall see that what kind of switch will give this kind of operation. And next, this is a single quadrant switch where it is a switch off state voltage and here it is switch on state current. So switch does not have a reverse blocking capability and in this direction, and switch does not have reverse flowing current capability in this direction. Same way some fax devices may require a bidirectional and current flow, where current can flow this direction as well as this direction, but it should be able to block the voltage in one direction and it should conduct the voltage in another. It can block the voltage in direction and this will flow the current in reverse direction. Same way we may require current to be flow in one direction and voltage to be flow either direction. So then the quadrant of operation is first and second. Here the quadrant of operation is first and 4. Same way we may require a kind of switch which can flow in either direction and it can block the potential in either direction. So then if it is possible by a switch, then or combinations of the switch, we say that this is a fourth quadrant switches. Let us see an application of it. Now a problem of the mechanical switch is that it will be a slope. So for this reason we require to actually apply semiconductor switches. Since semiconductor switches has its depletion layer and junctional potential all inherently inherit some amount of the blocking potentials. So for this reason these switches are basically active devices. And what is active switch? There is a difference between active devices and active switch. An active switch is one, it is controllable. So and there are devices which is half controllable, there are devices which are full controllable. Switches, active switch which state is actually controlled exclusively by another terminal, then it is called active switch. MOSFET, IGBT, these are basically the active switch, but thyristors or SCS are the half control switch, because it turn on is actually controllable, but turn off is not controllable. So, for this reason these are semi control or semi active switch. Same way passive switch, is basically the mechanical switches, though, and the current will flow whatever be the direction we can actually control. So, SCR is a special case, is a semi control switch, and turn on of the transistor in active device, while turn off transition is passive. So, SCS is a special case. And so, single quadrant switch is a on state and off state is unipolar. Example of the single quadrant switch are the diode. Since diode, if you refer to the VI characteristics of the diode, so V and I, actually it will this is a cutting potential, and in reverse if we will consider the ideal diode. So, this will be the zone of conduction and this will be the zone of blocking. So, for this reason diode is a single quadrant switch. Same way the diode is a uncontrolled switch, and same way you have a SCS, you have actually the BJT will be the control switch. So, this is the example. This is a passive switch because it does not require any control, and it is a single quadrant operation as been explained in the previous slide, and this is the pictures of it. So, it can conduct on state current and can block the negative offset voltage, and it provides the intended on state and off state operating point lie on the IV characteristics. So, then the switch can be realizing by a diode. So, which switch can be realized by diode? This switch can be realized by the diode. So, simple SPST switch will be realized by the diode. Now, same thing can be realized by IGBT without antiparallel diode or the BJT. So, you can see that in active region it is an active switch. So, there is a third terminal available. So, it is also a single quadrant switch because current flows this and the voltage blocking capability is this, and it can conduct only possible for this NPN transistor. This is the direction of the current flow, and of course, it can block the voltage in off state, and for this reason it can block the positive off state voltage. For this reason, this is also also a BJT, and difference of BJT and IGBT is just the gate voltage and the gate current. Here you require IB to make it on a cut off to the transition region. Here you have to apply voltage so that your gate current is actually power consumption in the gate is much reduced. But otherwise these two devices, as per the quadrant of operation, they are same devices. Now, let us see a same buck converter. We revisit the circuit using 2 SPST switch, which was been shown in the second slide. So, this is the mechanical switch SPST and another SPST switch. So, we can use these 2 SPST switches to realize it. One can be controllable, another can be uncontrollable. Generally we put a BJT or MOSFET or MOSFET inherently comes with the body diode. We will discuss it little bit later, but here we can put an IGBT based on the rating, and thereafter this we require another switch. This switch can be IGBT and also diode, and since control is not required, most of the cases this SPST switch will be diode, and this SP switch will be a transistor or IGBT. Now, this is the practical realizations of the DC to DC converter, where this switch, this is a controllable switch, and it has been realized, this SPST switch is realized by a IGBT or BJT. Here in this case we have put BJT, but problem of the BJT is that its efficiency, we require a huge gate current to make it operate. For this reason, most of the cases it will be replaced by IGBT. And here, since the control operation is not required, whenever free will action is required, for this reason we can, since it is T on and this is 1 minus T on, by controlling T on you can automatically control 1 minus T on. So, thus no control is required in case of the diode. So, diode will conduct rest of the time depending on the mode of conduction, whether it is continuous mode or discontinuous mode. So, this can be realized by these two single pole single throw switch. Now, let us come to the 2 quadrant switch, where the switch can block this voltage this much and the current should be bidirectional. Current can be this as well as this. So, let us see that which semiconductor switch can realize this diode. Now, this is actually the MOSFET. As we know that this is an N channel MOSFET, it comes with a body diode inherently. Thus, when let us potential 1 and 2, so it is controllable, because if you apply a positive gate voltage above the VTH, then current will flow in this direction. But if the voltage of the potential 0 is more than 1, the current will find its path through the diode. So, it can block by C, it can block this voltage and it can control this voltage and also the control this current, but current can be bidirectional with this switch. So, for this reason this is a 2 quadrant operation, and we can say that it is a DPST switch and can be realized by it. So, this is one example. This is an example of the bidirectional battery charger, where there is a little bit change. We had in this case buck converter, this was IGBT or BJT, and this was diode, since actually this was T and automatically it T on, and automatically this becomes 1 minus T on. So, in this case there will be a change in thing, then power can in the normal mode of conduction or the charging of the battery, power required to be flown from the point A to point B, but in case of the battery is supplying, then power required to flow B to A. So, let us understand what does happens. Now, most of the cases we require to buck the voltage to charge the battery. Battery bus is connected little bit of higher voltage. So, for this reason, this bucking operation is done by mostly Q1 and D2, and we can put same way here a MOSFET, so which can have a body diode. So, ultimately diode will conduct when it is actually in the freewheeling region, but when boost mode comes into the picture, then essentially then Q2 and the D1 come into the picture. So, it will be shorting, so actually there will be a huge voltage built up, across the void, and ultimately diode will be forward biased than the VA, and ultimately power will flow back to the main bus. So, bidirectional DC to realize bidirectional DC to DC converter, this SPST switch will be converted to the SPDT switch, and so this can be realized. Now, let us talk about bidirectional voltage and two quadrant switch. Here voltage can be bidirectional this way as well as this way, but current is unidirectional. This is realized by two one quadrant switches. Diode and this configuration make current unidirectional, and blocking capability of the current in the forward mode is been actually achieved by the control switch, but reverse direction it is actually this will be blocked by this diode. So, what is the takeaway from these switches? In active region, so the terminal C will control the flow of the current, normally operates in the two quadrant and can product positive on state current, can block positive or the negative off state voltage. One of the example will be SCR, but problem of SCR is it is a semi control switch. Your control turning on is in your hand, but turning off is not in your hand. Generally this kind of switches when used in current source inverter. The current bidirectional two quadrant switch. Here you can see that same thing, active switch is controlled by the C. Now talk about the 4 quadrant switch. It required to be realized by the active switches only, because it required to block current as well as the flow current when it is desired, since all the quadrant required to be incorporated in this circuit. Thus, can conduct positive as well as the negative on state current, can block positive or the negative off state voltage. These are the requirement. So, for this reason there are few realizations of this circuit. The voltage and current required to flow between point 1 and 0. So, this can be realized by the many switches. Normal mechanical switch is automatically of this configuration. Let us see that how this can be realized by the semiconductor switches. So, rightmost circuit we shall take it first. So, this circuit so if the V1 is greater than V0, then path of the current will be through this. And what happened? So, this, and if reverse happens, in V0 is greater than V1, then definitely current will be flowing by this direction. Then what is the advantage of it? This require only one control switch, that is one of the biggest advantage of this. But disadvantage is that it will have a loss, it has to incorporate losses of the 3 devices, because all it has is blocking voltages, and generally power diodes voltage is around more than 1 volt. So, we will have almost a 3 volt drop across these devices. Now, this is one of the realizations with less number of control switch. Another realization can be with this anti-parallel BJT or the IGBT. So, if same way, if this terminal is positive, then flow of current through, let us say, switch 1 and diode 2. And same way, if actually V0 is greater than V1, then it should flow through switch 2 thereafter with diode 1. So, in this case, this device will actually incorporate losses or we will have to face losses of the two devices, but in this case we require two control switches. Same thing can be realized by this configuration. This is asymmetric configuration, this is asymmetric configuration, otherwise there is not much no difference in this case configuration. So, here it is been made by SPST switch and here it is made by SPDT switch, that is the difference. So, this constitute one SPST switch and this constitute one SPDT switch. So, as far as principal operation or the number of the component count, all are same. So, this is the fourth quadrant operation of the semiconductor switches. What is the application of it? Application of is a 3-phase matrix converter. So, we want to have a generate AC to AC conversion, direct AC to AC conversion. These switches can can flow current bidirectional as well as block the voltage bidirectional. So, these 9 switches constitute the matrix converter. Direct matrix converter has a property to flow and block the voltage in either direction. Now, what are the summary of these switches? Ideal SPST switch can be realizing by the semiconductor devices depending on the polarity of the voltage which device must be blocked in on state and on the polarity of the current which device must conduct on the on state. Single quadrant SPST switch can be realized using a single transistor or a single diode depending on the relative polarities of the off state voltage and the on state current. And two quadrant SPST switches can be realized by a transistor and a diode connecting in series and a bidirectional voltage or anti-parallel, it is a bidirectional current, and four quadrant switches can be realized by two SPST or two SPDT switches. Now, let us see how this actually comes into the picture in fax application. So, inverter can be realized by the help of SPDT switches. So, this is the pole of the inverter and this is a two terminal 1 and 2 and this terminal point is A and B. So, the voltage AB will be connected to the DC bus voltage, positive DC bus voltage, if point A is connected to the point 1 and similarly point B is connected to the point 2. So, we can change this point, thus we can change the voltage across it. So, how can we realize this SPST switch? We have seen to DC converter. Let us see how we can do it the same thing for the inverter application. So, this is the application. So, this is a load and voltage is 0. So, this is basically the A and B. A the block, B block and C closes. So, voltage across it will be basically 0. So, our lower two switches has been closed. So, you are getting a 0 voltage. Now, free wheel diodes permits the current to flow through the switch 1 and opens. Thereafter what happened? Then this diode also permit the lagging current to flow through the inductive load, because most of the cases we will find that load is inductive. If it is for the drive application, it will be the induction machines, and if it is a fax application like the STATCOM and all those things, we shall consider the inductive loading. So, for this reason, you see that this is the direction of the current flow if we have applied this kind of voltages. So, ultimately this kind of voltage will come when this is a flow of current, and after that this flow of current will change. Now ultimately this is a basic realizations of the 50 hertz inverter. See that first A is closed and B is closed, you are getting VAB equal to VDC. Then A is closed and A plus is closed and B plus is closed, that means both the top terminal are being closed, so you are getting 0 voltage. Thereafter B is closed and minus A is closed, thus actually potential reverse. Again thereafter all the lower switches are closed, minus B and minus A is closed, so you are getting a voltage of 0 volt. So this is the actually the cases. So what we can say, why you require a 0 voltage? Because to match the volt area criteria. So this basically used to reduce the RMS value of the applied voltage. Now this is the your load characteristics. So we can see that if we can consider an lagging load and then it is feeding an inductor, highly inductive load, then in this case current will lag if we apply DC voltage VDC, so or VAB. So ultimately current will ramp on. Thereafter when you apply 0 voltage, current will be flattened, so current will flow through the diode in that region. Thereafter once you apply the negative voltage, then voltage will again comes into the place and voltage will drop, will have a 0 cross. Thereafter same will happen here in the plateau region. So this will be the, so what happen, by increasing this value you can increase or decrease the value of your RMS voltage. This is a operation of the simple square wave inverter. So what I want to say that the opposite signs repeats each other. So in this region voltage and current have the opposite sign with respect to each other. So again in this region voltage and current are in opposite sign. So what happened then? Then you got a forward voltage and negative current. So ultimately diode will conduct. So when you have a forward voltage and the forward current, then control switch will conduct. So it can be very well realized by the simply realizing by a SPDT switch. So this is few application, this is the direction of the current flow, assume that this is the direction of the current flow. So it is here or here. Thereafter what happened? So if we change it, then when current is actually ramping on, it is positive half cycle, then current will flow through these switches and these switches, and this will be here. And thereafter what happened? Current will flow through this, and in thereafter what happened? When current direction changes, then this will be the direction of the current initially. Thereafter diode will flow into the pictures, this will be the direction of the current, and thereafter this is the total circuits. So when plus A closes and plus B closes, you get VAB. When plus A closes, plus B closes, you get 0. When plus B closes, plus A closes, you get minus DC. When both these things are closes, you get also 0. So this is the operation of it, where load is generating power, and previously in this configuration we will assume that load is consuming power, because we have considered a highly inductive load. So practical real power loss in this system is negligible. Now we have discussed SPST switches realization for two level inverter. Now we shall see that by SPST switch how can use the current source inverter. Both are extensively used in the applications of the fax devices. So, in next class we shall continue with the switches. Thereafter we shall discuss about the difference of different kind of PWM techniques suitable for the two level inverter, and thereafter we switch over to the multi level inverter and followed by its control technique. Thank you.